Alright, to start review for our quiz, and we'll start at the top of this review. This section is from 10.4, and it's about inscribed angles. So inscribed angles means that the vertex of the angle is on the circle, whereas central, well, I could do better than that. Good enough. Whereas central angles, the vertex is on the center of the circle. So central angles, the angle is congruent to the arc. However, with inscribed, that is not the relationship that you'll see. You'll see that the angle is going to be half the intercepted arc, and the arc will be 2 times the angle. So in our first, we want to find the measure of angle K, which is right here. We are given the intercepted arc is 40, so the angle is half the arc, so the angle will be 20 degrees. In the second, it wants us to find DF, which is the arc for the angle 72 degrees. So the angle is half the arc is going to be double the angle. So we're going to do 72 times 2, which is 144 degrees. Alright, and then last, find the measure of arc ST. It is not an intercepted arc. So that means an angle does not start and stop on the edges of the arc. So we need to use other information to find the measure of this. I would say this question is one that students commonly get wrong on a quiz or a test the first time they take it. So make sure you look through this. If you'd like to see more, go ahead and email me, and I can find a few to show you. But some things you want to observe about this circle is we have this line. It goes through the center of the circle. That makes it the diameter. So because it is the diameter, the arc that starts and stops on the diameter, so that'd be SU, or STU, I should say, it's going to be 180 degrees. So all the way around from ST to U is 180 degrees. We are capable of finding, TU because it does have an angle. So remember, the angle is half the arc, and the arc is double the angle. So 61 times 2 is 122. So that tells me what this piece of the 180 is. To find the missing piece, I'm going to subtract. So 180 minus 122, which is 58 degrees. Because 58 plus 122 is 180. In this next section, it is from 10.7, equations of circles. So you will need to know how to plug in to the equation of a circle. So you're going to plug in the center here. So the x of your center and then the y of your center. And then r stands for the radius of your circle. So that would be from center to the edge, how many units away. So we're going to use this formula. I always leave it like this, leave space for me to just plug in. So I'm going to plug in the x of my center first. When I plug that in, that minus will turn into a plus. Now plug in the y of my center, and then I will plug in the radius. So the only thing left to do is you do need to simplify 6 squared. 6 squared is 36. So on the second, we're going to do the same thing. Let's scoot this over. We're going to plug in the x. So when I plug this in, x minus 0, a lot of students struggle with this fact, it makes x. Because if I have $4 minus 0, that's $4. So if I have x minus 0, that's x. Okay? So, and then in the second, I'm going to plug in my y, my center. So when I plug in that negative, negative, negative makes a positive. So my second parentheses will look like y plus 9 squared. And then last, I'm going to plug in my radius. So remember when we did this in a previous chapter, the square root of something squared is that number, because squaring and square roots are opposites of each other. They undo each other. So the square root of 3 squared is 3. And then last, x minus something squared plus y minus something squared equals the radius squared. Plug in the x, plug in the y, and then plug in the radius. It just dawned on me, if you hear the ocean in the background, that is my son's sound machine so that he naps. So sorry if it bothers you, it honestly calms me. And then the last would be 10 squared, which is 100. Ta-da! So match the graph to its equation. So it's the same concept we've been talking about. You're going to match the equation of the circle to the picture of the circle. So something to notice about all of them is that they all have the same radius. The radius is not 4. The radius squared is 4, right? Because that's where the radius squared sits. So the radius is actually 2. And when they plugged the 2 in to the formula, 2 squared is 4. So they all have the same radius. So really, the only thing that differs them is the center. So we're going to need to figure out the center of each of these circles and match it to the graph. So I would say the center of this first circle is here. You can do this a couple ways. I'm just going to look at the graphs and then find the center in either A, B, or C. So my center, remember every coordinate is an x and then a y. So the x is over 1, 2, 3. So 3. And then up 0. So that means when they plug into the formula, it should look like this. Because when you plug in y minus 0, remember y minus 0 is y, and then squared. So that means it will match B. So I'm going to put a B here. I have seen students point before. That's really confusing. The second, or number 8 I guess, the center is here. It is at the origin 0, 0. So when you plug in to the formula, when you do x minus 0, that ends up looking like x. When you do y minus 0, that ends up looking like y. So that would be A. And again, they all have the same radius of 2. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. They all have the same radius. So really, by process of elimination, we know 9 has to be C, but just to prove it, the center is negative 3, because it's over 1, 2, 3, and then up 0. So when you plug in to the formula, when you plug that negative 3 in, it's going to make it into a positive. And then again, when you plug in 0, it goes away. So those are your answers. You got B, A, and then C. B, A, and then C. So these next few, they're inscribed shapes. They're all quadrilaterals. And this is from 10.4 again. So this is where opposite angles are supplementary. Supplementary. So that means we could do this a couple ways. If we're going to find the variables, the value of each variable, we can start with x. J is across from L. I know that they add up to 180. So, because they're supplementary, that's what supplementary means. 180 minus 110 is 70. So I know that 5x has to equal 70, right? But that is not what x equals. To find out what x equals, we're going to divide by 5. I believe it's 14, 50, 20, yep. So x is 14. We'll do the same thing for y. These two are opposites. So if m is 104, that means this one is equal to 76, because 180 minus 104 is 76. So 2y equals 76 divided by 2. So y will equal 38. Alright, this next one is a little bit different. So the first thing we can do is find x. That's simplest. X is across from 108. So 180 minus 108. X will equal 72. This next one, you have to know that these arcs, mean that they're congruent. If they add up to 180, you're going to split 180 into two congruent pieces, which makes 90. So y equals 90. This next one, you're going to have to put some pieces together. So, this one deals with arcs, the intercepted arcs, and the angles. So, we're going to have to figure out, let's find angle A first. Okay, so to find angle A, I need to know it is half of the intercepted arc. Well, what is the measure of the intercepted arc? So it'd be this piece, right? So add those two together, 152 and 80, and you get 232, right? 13, yep, 232. So we're going to ignore these numbers now. If this piece is 232 degrees, and I know its arc is going to be half of that, I'm going to split 232 in half. So 232 divided by half is 116. So that's the measure of that angle. I'm going to erase a little bit. Because remember, my goal is to find x and y, and they are angles, not arcs. So I need to know the measure of the angles. We will do the same thing for angle B. Angle B's intercepted arc is all of this. So we would add 84 and 80, which makes 164. And then again, the angle is half of the arc, so it'd be 82. So this still, we haven't finished the problem. We still have to figure out the measure of x and y. So we know angles across from each other, like 4x and 116, they are supplementary. So 180 minus 116 is 64. That means 4x equals 64. divide by 4. X equals 16. So for y, it's across from 82. So 180 minus 82 is 98. Sorry, I'll erase some. 98. So 7y will equal 98. Divide by 7. Y equals 14. Ooh. So that's all of the new review. We're going to review the commonly missed questions on the previous quiz, because this next quiz will also have similar questions. So it says name two pairs of congruent angles. So this is where we learned if two intercepted angles shared a spot on the circle, that means those angles are congruent to each other, and their arcs, because their arcs are congruent. Their arc is literally the same measure, and the angle is going to be half the arc. So this arc was 100. That means this angle is going to be 50, and that means this angle is also going to be 50. So we need to name them. We'll name this blue one first. We can't say X, because X, there's, oh no, we could say X. Here's Y. This is not an angle, it's got a curved portion. This is not an angle, it's also a curved portion. So we could just say angle X is congruent to the purple angle, which we would name by the vertex angle Y. There's also another pair of congruent angles, and it would be this one and this one, because again, they share spots on the circle. They have the same exact intercepted arc, so they'd be the same measure. So if I wanted to name the green angle, I would say angle W. If I wanted to name the red angle, that would be angle Z. As a refresher, because some of the questions on the quiz are multiple choice, if you ever need to name an angle with 3 letters, so like let's say I wanted to name this angle in 3 letters, W would need to be in the middle. So I could say XWY, or I could say YWX, same thing. And then if I wanted to name the other angle, 3 letters, I could say XZY, or I could say YZX. Oh no! Okay, so long story short, if you just heard me yell oh no. Before sitting down to working, I had put cookies in the oven because my kids are sleeping. And I didn't want to deal with my daughter because I don't share food. I don't know if y'all know that. Well, I mean, I share, obviously, I feed my child, but I'm not going to share my cookies. No. So I made them during nap time so that I didn't have to fight that battle. I heard my timer go off, probably at the beginning of this video, and I was like, what in the world? Why is this timer going off? And it's because my cookies were done. So let's just say they're black, and they're bricks. And I'm very sad because those are the last ones. Yep. Moment of silence for my cookies. Okay. This is why God gave us husbands, so they can go get me new cookies. I'm kidding. Kind of. Find the measure of arc AB. So arc AB is going to be congruent to arc ED. These are central angles. Central. So, because they're central angles, the arc is congruent to the angle, but that's only in central angles. So if the angle is 61, the arc is 61, and since the arcs are congruent, it's going to be 61 degrees. So the last two, tell whether the red arcs are congruent, explain why or why not. So in order for arcs to be congruent, they need to have the same radius, and they need to have the same measure. Same radius, same measure. So in our first red arc, and our second red arc, if you're not paying attention, they do look like they are congruent, but they are not. Reason being, they don't have the same radius. So the radius for this first arc, the radius is from the center of the edge. And for the second arc, center of the edge. So they're not going to have the same radius length, so they would be not congruent because they don't have congruent radii. So, okay, I'm just going to say radii are not congruent. Alright, and then last, it looks super confusing. But if you break it down, really, you've got a circle. Okay, and a piece of the circle is the arc in question. We have, these are the radiuses of the circle. In our second circle, these are also the radii of the circle. So the main piece that you need to see is this in the middle. They actually share a radius. If I were to take them apart, this first one, ooh, this is not pretty. It is what it is. The first one has a radius of 6, and the second one has a radius of 6 also. They share this line. So the radius is the same, and then you need to make sure that the angle is the same. These are, again, central angles, so the angle is congruent to the arc. So because both of their angles are 95, then that means the arcs are 95. So this would be yes, because they have congruent radii and congruent angle. I would put central angles. Ta-da! If you have any other questions that you want me to go over, please email me, and I would love to go into detail for you.